Hello everyone, I am Bradley Sword, Associate Professor of Computer and Information Science at the College of DuPage in Glen Ellen, Illinois. And in this video today you can see the long-winded text, but basically we're going to be taking a vector and we're going to be searching this vector for a specific value, and we're going to try to find the element in there that has the closest match. So as long as the vector is size 1 or larger, it's not empty, there will be a closest match to any value that I pick. It might not be identical. Maybe it will. Maybe it won't be. But we're going to find the one that closest matches. And then once we have that set up, I'm going to use the integer data type to get that thing started. And then once we have the thing going, I'll show you guys how to do function templating to finish off the deal. So there's a bit of setup here. Let me just explain it real fast. So the first step today, we're going to take a look at searching an integer vector for an integer value. And then afterwards, we're going to take a look at templating this thing so it'll work for any data type and not just the integer data type for a vector of type T. And then I have a bunch of test cases here that we can test against to make sure this thing is working so that we can find the closest values in that map. So let's kind of take a look here. So I say the purpose is to find the closest value. The return value is going to be just a plain old integer because I just want to return the closest value. And then so the function is going to be called find closest value in vector. And then two parameters here, the vector of integers. And depending on how you want to process this, you might want to think about making this a constant. I'm going to make it a constant. Again, if you wanted to take 2 passes through the vector, you could do that. That's one methodology to do that, is to kind of modify the vector and then go ahead and basically figure out which element has the smallest delta value. But in this case, I'm going to just process the vector 1 time over to get the job done and figure out which element is the best one. So I want to take a const reference, and I'm just going to call it v for the vector, and then I'm going to say my search value is going to be an s. So at some point along the way here, I'm going to return some value after I process this value looking for that search value. So one thing of note here is that it does say that I should throw an exception if the vector is empty, because what would I do if I'm looking for a value in an empty vector? Other than crash the program, I probably should throw an exception and have that triggered and caught on the other end from whoever is going to be using this thing. There are other ways to do this, but for the checkpoint example that I'm doing here for my class, that's the methodology we're going to be doing. So if v.size or v.empty, that's probably an easier one. I always say to use empty if you can. If it's empty, throw an exception. And I know some of you are not working in a Microsoft compiler, but for whatever reason, there is a difference here between the Microsoft compilers versus other compilers when it comes to setting up the base exception class. And I just want to put, what am I going to throw here? Just say vector is empty. I'll just put, and I'm not going to put anything more. I could put something more verbose in here, but for this example, I'm just getting the point across. You know what this means. So that handles these, basically the empty vector. But other than that, everything else goes. So at least from the standpoint of this function, once I throw this exception, I don't have to worry about an empty vector anymore, and I can do everything I want from there on in. And since I know my vector is empty, I know there's at least one element in this, and I can say the best index in which, at least to start off with, is the first index. Maybe there's only a size of 1, and then therefore it is the best index, but otherwise we have to process everything. But for right now, the first index is the best. So I'll just say my index is 0, and when I return something, I'm going to be returning a value, not an index, but I want to return the value at that index. So I'm just going to be returning the v at this, whatever index is the best index according to the calculations we're going to be performing. We want to return the value at that index. And so now we just want to process this vector 1 by 1 by 1, and I'm just going to use a range. I can use a range-based for loop. No, I can't use a range-based for loop because I have to keep, at least the way I'm doing things here, I have to keep track of an index. So I'll be using everything from index 1 all the way up to, but not including the size of my vector. And I'm going to be processing them 1 by 1 by 1 by 1. And so at this point, you just say, well, if, and this is where things can get a little tricky. And let me just put this in here and just put some stuff here. So let me backtrack that for just one moment here. So I'm going to say we have to keep track of the differences because the point is to find the closest value, the index with the closest and the smallest difference between the value stored at that index and my search value. So for and again, I'm not going for 100% efficiency here, but you can kind of get the point here. So I say, okay, what is the difference? Difference 1 is the absolute value of whatever my search value is and whatever is stored at the current best value. So in this case, that would be whatever is stored at my vector at the index value. So this is, and the absolute value just makes sure that I get rid of the negative sign. So I want the magnitude of the difference. I don't want that negative sign to affect the calculations that I'm going to be performing. And then it's just basically the same kind of thing here for whatever's stored at this I index, sorry, I versus index. But index is the best index right now, and then this is everything else that we're attempting to figure out. So we have two differences. This is the, so essentially if difference 2 is going to be less than difference 1, then we know that whatever's at this value is a better pick than whatever's at that value. And so if that is the case, where I go, okay, cool, I have a better index, well, right, basically I just want to say the index value is equal to that I value. And then I just keep on going, keep on going, keep on going. So this might actually do it. Let me try the first test cases here for part 1, and let me just make sure I turned off the test cases for part 2. So let's see if this goes, let's see if this compiles, you never know. Oops, something is wrong. So, oops, what do I have going for me here? I have external, blah, blah, blah. This is a linker error. This is, oh, that's because I don't have this actually inside of my source file here. Let me try it one more time. Don't mind me there. I think everything is going to come about now. Maybe, maybe not. Let me just build this one more time. Let's see. And as it turns out, I was supposed to comment out the part 2 test cases. But once I do that, everything else kind of comes around. At least for these first test cases, I could run this, and you can see that the 4 tests pass that I have here. Let's kind of go through the description of what those are real fast. So I say, okay, here's my vector. I'm searching for a 7. It's in there, so it better be a 7 that gets returned, and it does. And so for the second one here, I have I'm looking for a 5. And there's a 4, and then there's a 7. And again, like which one's closer? In this case, the 4 is the closer one, and that test case works out just fine. And for this one too here, I go, I'm looking for a 4 in here, and I have a 3 and a 5, and 4 is right in the middle. And I just kind of came up with the rule that whatever comes first in the vector is the closest one. And just to make it, just to make the code easier, especially since this was a checkpoint problem for my students. So basically, if I'm going to pick, if it was reversed and I say, oh, the 5 came before the 3, then it would be a 5. It's not just whatever's the smaller value, it's just whatever came first in the vector. So looking for a 4 between a 3 and a 5 will return the 3. And then finally, if I have an empty vector, it doesn't matter what I'm searching for, it doesn't even matter what I'm looking for. It's going to throw an exception, and it's going to fall down here. And notice it doesn't say that it failed because it threw the exception, came out of the try block, came around to the catch, and says that it passed because it found what it was looking for. Take a look at this one last time. Everything passes, all tests pass, and now we're good to go. So here's the code one more time just to kind of take a look at what's happening here. And again, you can kind of reduce this down. You could reduce the amount of code, but it doesn't reduce the amount of like actual code that's being generated by the compiler at the end of the day here. So that is how you would cover this first part. One of my personal rules of thumb is, especially when I know I'm going to be creating a templated function, is to get it working for a base data type like we have here, and then think about producing the more templated version of that. So this is a good starting point because we already know half of the test cases for our example works. And so now just to kind of keep things going here and go, okay, let me turn on those other test cases for part 2. I'm gonna have some code here in a minute. This is duplicated here for the time being. But let me undo all my commenting from before. It kind of threw me off for a minute there. I'm like, why am I getting these weird errors? Okay, so now, and right now we're going to get errors because there's no templated double version, but we're going to fix that up here. So now we're going to turn this int type into a type that is for any type. And template type name T. Some of you like template class T, which is fine. I'm going to return a T type because whatever is the vector, whatever, oh, get out of here, whatever you are. Nope. Come on. Oh, whatever. Okay, so whatever the t-type is, that's the type, that's the vector of t-types. Whatever a vector of int, well, it's going to be a vector of float, or vector of bool, or vector of who knows what that we're searching for. I mean, it could really be anything that we're looking for, and we're going to return an element of that vector, and we're also searching for a value that's the same type as the vector type itself. And why is this so stupidly crazy? Just get out. I don't care. Just go. Go. Nope. It will not let me. Anyway, it's not a big deal, I suppose. So now I just have to kind of go through the rest of this and figure out what do I care about and what do I change, because not everything always changes. Because like if I was searching the vector and I said, oh, I'm going to create a templated function that tells how many times I find a value inside of the vector. And you go, well, that's not going to be a t-type. I'm not going to return a float type when the number of times is a pure integer value. So not everything turns into a t just because I'm templating the function. All of this does because for the t-type, I'm returning a value of that vector with the search value of the same type. But let's see, anything else? Any other places where I'm setting up a variable and I go, well, this isn't going to work. Int, nope, this is fine. I don't have to change this because an index value is always going to be an integer value. This index value, the only thing might be here just to kind of change this to a size t, and maybe change this to a size t. And for those of you who are, like, what the heck is Brad talking about? You can even look here. You can go to the definition of a size t, and it's just a fancy standard template library version of an unsigned integer value. And I know I was getting a warning. That's why I wanted to come back and kind of fix it up. I was getting a warning when I would do my build. And that's kind of how I can avoid that. So I can keep those data types. And I don't have to t-type it at all. But these two guys here should be t-types because I'm taking I'm taking elements from the vector, and every element in that vector is a t-type. But everything else now should kind of come along for free because basically this is the only thing that doesn't get modified whenever I'm setting up my other values. I believe that does it. Oops, I still have a warning. I'll fix that in a second here. But you can see now that all the integer types passed, and we had a compiler error a minute ago, but now all of those other tests pass as well. And I think we're good, but let me check that warning. What line number are we at here? Oh, and we can also use a size t here. And for those of you who are taking the checkpoint and just watching this video, the size t is something that I'm not going to be worried about, but it's just something to get rid of those pesky warnings. Sometimes those warnings can be just as bad as errors, depending on what you're trying to accomplish here. So this is how you would set up, and that's the answer to part 2 that I'm looking for. You just need to change most of the integers to t's, leave 1 or 2, and depending on how you solve the problem, you might have more complicated code or even more simple code because you might be able to make this even more simple. I don't 100% know. I haven't thought about how to make this as efficient as possible. So that is what I was going for this problem. So if you have any comments or concerns, as always, you can comment below or you can email me at swordb@cod.edu and I will get back to you as soon as I can with that understanding. So thanks everybody for sticking it out with me as always. Have a nice day. I'll see you guys in future videos. Take care. See you then.